It's my great honor to introduce the next speaker. The next speaker is Lucio Blandini from University of Stuttgart. He's head of ILEC department, Institut für Leichtbau, Entwerfen und Konstruktion, which was founded by Werner Sobek, one of the great minds in structural engineering and connection of structural engineering and architecture. And Lucio is the head of this department, following the tradition, and we are looking forward to your lecture.
Thank you a lot for the invitation. It's a pleasure to be here. Now I have to switch in the meantime and keep talking, but multitasking is a lot about our job, and perhaps just to add something to that, talking about multitasking. I am at the same time a board member of and a partner of the Werner Sobek office. And no, I don't want to have it now. Now, and as I was saying, multitasking is relevant nowadays, and I believe, Helmut Pottmann has introduced the relationship between academia and praxis is relevant if we want to bring our innovation in the built environment, and so this is one of the reasons why I'm still doing both, and why I'm presenting lightweight from the perspective of the practice and from the perspective of the research, just to also to expedite and support the transformation, which I believe we all agree it's needed. So let me start with my understanding of what lightweight in the practice is, related to my work, but perhaps since everybody has been presenting himself with a kind of background, I'm a structural and facade engineer with a strong passion for design and architecture, and with a belief that just an integral approach is the only one that we can use if we want to get into a really transformative process. And so I want to start a bit talking about my background and my understanding of lightweight with a project, and please allow me to start with an Italian project for Ferrari. I mean, it's kind of a dream of every Italian designer to work for such a company, and I had the chance to make the overall facade engineering for this amazing museum designed by Future System. And that was in almost 16 years ago, my first attempt to combine together lightweight design on one side and parametric computational approaches on the other side. At that time, it was a lot still with AutoCAD, with Lisp, for the ones that remember what that is about. And the idea is to achieve lightweight construction which are easy to be produced. It's something that, of course, nowadays is I would say, mainstream, and this is good so. At that time, it was still kind of pioneering work, not only defining where exactly all the profiles are, how they are defined in terms of not only geometry, but also in terms of production processes, and how the detailing is allowing to achieve that complex geometry that was required. I'm not getting too much now into geometry, but if you have any questions, I can go further into that. I mean, there's a lot about geometry today. But to me, the question is how we can produce lightweight system in the practice. Yeah? And I want to shift to another project, and that was probably not the case that after Ferrari I've been asked to find solutions how to engineer this structure, shifting or transferring methods from facade engineering in a way into concrete and free-form concrete calculations. And what at the end I did is to generate and create a process to shift from the original Rhino surfaces from that came from Ingenhofen as a designer, as an architect, into a finite element calculation on one side. At that time, there was, and again, 10 years ago, so bear with me, it's a bit an historical background. At that time, there were no software yet, just defining, for instance, something like a middle surface out of two surfaces which are not parallel, which is a trivial question in terms of geometry, but in terms of implementation for the engineering practice, it was not. And we've been programming ourselves, and that has been a kind of path linking our work in the past. Wherever there is not yet a software then supporting us, then we create our software ourselves, or we create our add-ons on the softwares ourselves. And so we did the all pre-processing to get to the finite element system, which is at the top, just by our own, and it has been scripted in such a way that it has also such a kind of really regular mesh, which was nice for our colleagues from the structural mechanics not being able to see this in a finite element program implemented. But the point was to go further. How do you build it? How do you generate this form? It's a free form. It is not analytical describable. It is coming from a form funding, which is something, by the way, you associate traditionally to lightweight. What is the form which is related to that? I mean, we've been hearing about minimal surfaces, and so minimal surfaces, or such kind of surfaces, I don't want to generalize at this time, are at least using the methods coming from the experimental methods coming from the school of Fra Giotto, which is, by the way, the very first founder of the institute, if we can consider that. The institute at that time was just called IL, Institut für leichte Fleckentragwerke, 60 years ago, so we also have a kind of jubileum anniversary on that. These surfaces cannot be easily implemented, and the question is, how are the rebars looking like? It's a very engineering question, but it's not, again, not a trivial one, and once again, we've been engineering parametrically the all rebars in Rhino, scripting the rules to get that, combining geometrical issues and engineering issues together in order to get the paths of the different rebars and get it segmented in a proper way so that it could be built. And at the beginning, the construction company, the contractor told us, it's not buildable. You can see on the right image, it is buildable. And they've been relying a lot on our models. And of course, there's been a last step in the work we did together. And the third project, sorry, I'm going to show, and you can, I believe, acknowledge there is a path between the different, and there is a link between the different projects. Is in Kuwait, Middle East, architect is Foster and Partners. And we've been, in this case, asked by the contractor, by the general contractor, to make it work. There was a preliminary design made by Arup, but from a preliminary schematic design, no matter how you call it, to make that buildable, it's again a kind of special challenge. And once again, we've been starting from a parametric description of the geometry. There are papers on that that you can get deeper into that. Regenerating everything in Rhino, so same process as we did for Stuttgart 21, and then from Rhino, I'm not going that much in detail now, from Rhino creating a link to Sophistic as a finite element software on one side, to Revit, better say to BIM, to the BIM platform on the other side, and the kind of triangle between these three different platforms was a continually iterative loops of iteration, optimization, changes, certain profiles are not available, whatever, which has been all scripted. And that was the basis, the kind of structure of the process to build on to make that buildable. Interesting enough, this project is 10 times bigger than Stuttgart 21, started 5 years later, and they've been completed on the same time. And I'm not going that much in the political aspects of that. I think we could talk for a long time on it. But the point is, what are the changes on the technical side? And on the technical side, we've been, of course, developing the system further in terms of the process, but we also been using a different way of prefabricating, so that the surfaces generating or building the shells, it is a shell structure, 37,000 panels, 6,000 different geometries. I don't need to tell to you what that is about, because I think it's becoming more and more, at least for this kind of project, standard. And to us, dealing with such a limited time frame, that means we have to script it in such a flexible way that that we invest some time at the beginning building up all the process, and I've been kind of telling to the client, bear with us. It was not always easy, but at the end it has been paying off. And the fact that prefabrication was happening on site, so this what you see is just one element. So around 10 square meters, double curved surface, with an adaptive molding system. For the one that don't know the technology, that allows us through this hydraulic cylinder, you can see on the bottom, it allows you to, out of a classical rhino surface or something similar to that, to adjust the cylinders, and then there is an interpolation through the membrane, and then you get the surface within certain constraints, the surface you want. What for me that means we have 85 of these machines. They are machines, and within 1 year we produce 37,000 different pieces. And for us, that was in a way the technological easy part, which we could rely on to say, and now these are the surfaces. I don't need to tell you, all the connections are all different in a way, but of course this is the result of it, and if you set it parametrically, then it is achievable. And this is the biggest part of the dome. It's 100-meter span. We have several of these, and they are parametrically set. So such a parametric description for us, it was the perfect assist to develop further the methods that we've been developing. The last one is a membrane, and it's in Dubai, and it is about, and you can see it on this mock-up on the right side, is about shifting from a classical continuous membrane to a membrane where we really use the path of forces as a ground to design and build a pattern which is at the same time architectural, formal, and structural. Placing the fibers is exactly what we need. In a way, it's classical lightweight, if you want. It's a materialization of a flow of forces, but it becomes visible and it becomes part of the architecture. And this is what I was meaning with integral design, and this is actually what it is beyond my work as a practitioner so far. Now, that was kind of quick introduction, but I will speed up on the rest to bear with the time, because this provides the kind of ground for why I've been going back to the academia and what I'm doing there and what I believe the next steps could be and what could be relevant for you eventually as researchers. And the main question is, what is the future role of lightweight systems? And being the head of the Institute for Lightweight Structures with such a kind of overarching tradition, it's of course the very first question that I have to deal with. And so I would say the three aspects that not only me, but I believe most of us are dealing with currently in terms of challenges, but also in terms of chances, are resource efficiency, typical domain of lightweight system. We can talk about traditional, classical lightweight in terms of optimization of forms, optimization of materials. But more and more relevant are becoming issues like climate neutrality, up to a positive effect to the climate, and circularity in terms also of reducing the amount of waste. So this is why I'm postulating a shift from lightweight in a traditional way to what I call it extended lightweight approach, which has as a main focus a light ecological footprint. And it is not the same, because at this point, and there are a lot of people dealing with optimization, this becomes a free parameters optimization, if you want. And so there are certain applications that traditional are parts of the lightweight realm, which are still fitting pretty well to it, but there are some others which are, or some examples which are difficult to be recycled, for instance. Then one of the free parameters is not fitting, or there are others that are very lightweight, but not effective in terms of greenhouse gas emissions. And then there is another part of it which is going down. And so we have to find, in my eyes, a balance between the three if we want to impact the built environment facing the challenges that we have to face. And of course, this is a perfect setup also in terms of creativity and in terms of interdisciplinary setup that we have to face these questions. So there is a shift from what I'm taking with me in terms of practical background from the practice using digital tools into the attempt of enlarging the field of work in terms of making sure that the solutions we are proposing are not only effective in terms of mass reduction, but also effective in terms of climate and in terms of waste reduction. And so I'm going to now to present the two main big fields of research that we are focusing on over since several years now, since at least here in this case, since 8 years. Trying to have a look, kind of holistic look into these aspects. So one field is adaptivity, and the other field is going to be lightweight concrete systems. And I will explain why we picked these two. But let me say one thing about that. The nice challenge about working with lightweight is you are not pushed to work with one singular material or pushed to work with one singular technology. And so we try to see what is the best material. There is a tradition in Stuttgart to that. What is the best possible material for what we want to do? What is the best possible technology for what we want to do? So it's pretty open frame. And here we use adaptive systems just because we believe that a dynamic, transformative architecture could answer to a certain extent the need for more sustainability in the future. And I'm starting with this high-rise building, which we call D1244. It's our demonstrator building, 12 floors, 36-meter height. What is the specific thing about this building? It is a demonstrator, but it's a research platform. It's a research laboratory, and more than that, it can move. And you can see if you look at the top that the high-rise moves, I can say you around 15 to 18 centimeters, which is not that much, but these allows us to get to a reduction of structure of around 50%. And the idea behind that is that usually when you design a tower, a high-rise building, then you have to make it stiff enough that the people living and working on the top are not feeling uncomfortable about that. It's not about the structural safety, it's about the comfort. So if you now have a building that is moving or correcting, better say it, back movements that are coming from the wind, now you use only the structural amount you need to have the system safe in terms of strength, but you don't have to look into comfort issues. So safety is not an issue, comfort is addressed by hydraulic system. And this is the idea behind that, because a lot of people always ask if the system is moving, is it safe when there is no electricity coming? Of course it is. And this is a bit the kind of idea behind that. And so now the scientific questions behind doing that is where to place what we call the actuators. So the hydraulic systems that correct the form and manipulate the form in a proper way. And we have placed 24 of them. There is a redundancy on it. This is typical. It's an interdisciplinary project, so we do work with mechanical engineers, with system dynamic experts. We do work with computer scientists to make that possible. And you see at the ground floor the biggest parts of hardware that we are using. And there's going to be a version 2.0 because I told them it's too massive to be presented in a lightweight presentation. And there's much more that can be done out of it. But the point is, as always, is budget. And that systems were coming out of the shelf, and so we have to make some compromises there. We are looking into other systems with other materials here, concrete based on hydraulic elements. I'm not going to go further in detail now because of time, but I can go further into that. And the other aspect are the skins. Now, the nice thing about such a tower, and I told you I'm not only a structural engineer, but also a facade engineer, is that you have 12 different floors that can be cladded in 12 different ways. Very simple. And of course, we want to take the opportunity to experiment on 12 different systems. And so we are now starting the transformation of the tower, since that was one of my main projects since 3 years. And we are at around 1/3 of cladding. We will get to half of it next year, and to hopefully 100% in 3 years when there will be the exhibition, the international exhibition in Stuttgart. So you're all invited. Now, what is the first that we did? First of all, you saw these hardware machines at the ground floor, which usually would be a technical floor. They don't look that kind of appealing in a way. So we brought a soft skin to that, which is using the idea of fiber placement in a proper way, so that it's based on, there is a link with the work we did in Dubai. And here we move it further. So on one side, we make it movable in a different way. In Dubai is also movable, but it's a covering. Here it's a facade system in collaboration with colleagues from the mechanical engineering. And in that case, it was relatively easy just because it's very light. And we use two different fiber systems, basalt and glass, which are both fully recyclable. So you see there is always this component which is part of our work. And on the back of the ground floor, we wanted more to play with interaction, engaging people, just because there is always a kind of fear about using technologies, especially if they are not known. And so we say, why don't we invite people to touch the facade? And there is an actor behind that. It's a magnetic system, and you will feel the bit of the facade. This is a bit what we are telling to kind of trigger interaction. And on the other side, there is a similar facade, and so people can interact to each other without seeing them. And you can play a lot of different scenarios. I mean, I can see links with also how this can become element in the kind of more urban context, and it's why we did it at the ground floor, of course. And we can play a lot of different scenarios once we set the frame and the frame is there. On the second floor, we've been working with sun shading. It's a totally different topic. So every floor has its team. It's a different research group mainly. And here the question is, can we place a shading device which is reacting to two different aspects, to the solar radiation? It's not new. But integrate that with the possibility of having a different movement on the lower part, the so-called lower wings. So you see the upper and the lower wings. and so that there is also a different control about glare, about comfort, that we can accept for. It is currently exhibited in Rome for an exhibition curated by Elisabeth Diller. And just for the ones of you that want to see how it's going to look from the inside, here's a small video with a presentation about how you can, in an easy way, it's cable-driven, control in a different way the upper and the lower system with a high degree of robustness. And of course, the nice thing is you can change the panels, the infills. So this allows for a lot of freedom in terms of design, which is of course relevant to all of our projects. The next facade I'm going to show is focusing again on one completely different topic. It's about water management. It's about rainwater management. So it's a facade. It's a multi-layer textile facade, which is in the position of absorbing rainwater when there is too much. And this is unfortunately a case that is coming more and more. And the water can be used in a decentralized way during the day, during the weeks, but it can be also intentionally reused in the summer when it's about cooling down the environment around the tower, which is also helpful. And we find out that by the system that has been developed, it's called Hydroskin, we can affect the surrounding for 15, 20 degrees in terms of cooling down the temperature. It's an evaporation process, but it's a way how to make that possible. It's in a way an alternative to green facades. Green facades work pretty well until a certain height. I hope there is nobody from Bosco Verticale here, but of course the more you go to the top, the more difficult all is, and the more it's not really lightweight what you have to do there to bring everything, all the loads down. So no matter how nice such green towers are, they have a high cost that have to be paid. What are we planning until next year? So we are planning to work on ETFE cushion systems, working on the interlayers. Here it's a sun shading system, which is more related into folding strategies embedded into the cushion. We do work on switchable glasses using liquid crystal technologies. And here we engage different logic of controlling it. So you see every floors will show one approach, will show how manifold the solutions can be, and how that can be. It shows also the work that we do with our students that are even pushed farther to explore what a transformative, adaptable architecture could become in the future, so also in terms of vision, in terms of, let me say, in terms of dreams, in a way, because I think we do need this part as well. And at the end of the day, beyond the use of adaptive technologies, the overall project is about transformation. It's about dynamic. So the tower will show over a time frame of 10 years how architecture could become more and more transformative, so beyond the technological aspects. And I believe that could be an interesting contribution then to the overall discussion. So, first field. The second will be shorter. I hope still that I'm good in the time. Concrete. So you would say lightweight and concrete. Does it fit together? I mean, we got already the same question when it was about clay. And how can we build light with clay? And now is my approach to an extended lightweight concept where you say you have to do a light, sustainable concrete research because concrete is the most used material in the built environment. If you manage to address that in a good way, then you have a big impact. And this is why we picked that. But of course, we cannot build with concrete the way it has been done so far. I think we all agree on that. And so we bring there our approaches in terms of lightweight systems. And so you see there are porous systems. I rely on the work on graded concrete, which has been developed by Werner Sobeck since 15 plus years now, and I develop it further so that now we can use the holospheres, combine them with a pumping system which is automated. It's not rocket science, but the nice thing is we are going to have the first graded concrete foundation hopefully poured next year. And it is going to be within the frame of the new robotic laboratory of the University of Stuttgart within the cluster of excellence. And that is also part of the transformation I was referring to. So if we manage to reduce 30–40% of concrete use in all the foundations, and everybody dealing with foundations, even if they are not visible, knows that there we're talking about 1 meter plus. You don't see it, but it makes a big impact. And the same thing can be applied, of course, to slabs, where we use that, where we've been developing digital tools to optimize how the layout of the spheres, of the holospheres can be. And so that at the moment we are preparing the production of around 20,000 to 30,000 holospheres to get it built. And then it will be shown that we can scale it up. And I think this is an important part of it. You don't see it, but actually gradations could be very nice. And this is the motivation where we've been looking into the chance of filigree concrete structures from the different perspective. How can you make this flow of forces really visible? And this was the idea behind this demonstrator, this installation we presented in the Biennale, or within the frame of the Biennale in Venice, last year, which is nothing else than a materialization of forces visible. And now the question is, how can you make it? How can you build it? And you see there's always a question that is driving us. And we are using additive manufacturing, but we are printing the formwork. And we are printing out of sand, and not out in that case. With a similar approach, we can gain 100% of the sand. The previous approaches were using materials for curing that could not be, or that lead to a kind of waste issue out of the formwork. We have biodegradable systems where we can wash them and get the same again. So it's not only about reducing mass, it's really about reducing the impact. And now just a very quick a quick video about how we start from a continuum and we generate a lattice system following the flow of forces and providing, of course, some constraints. How thick can every element be? Printing the formwork out of sand. You see the one which is the part which is not cured can be really easily taken out. Here we use carbon fibers only on the top part. It's a cantilevering system. All the rest, it's all in compression. You don't need it. But actually, we are already working on a more on an alternative solution, which is a better ecological impact than carbon, because this is always an issue. And yes, we were hoping on a sunny day in Venice. It was not the case. And still, we built that within 8 hours. And we dismantle it with the same speed, and we are going to rebuild it again in Stuttgart in front of the institute. And this is also part of it, that these demonstrators are conceived in such a way that this is valid also for the tower, by the way, that can be dismantled and rebuilt again, or pieces can be taken out. So the circular aspects to that, they are gaining on weight. And then just to close, a totally different kind of outlook about what concrete could or mineral system could become. We know that cement is responsible for around 8% currently of CO2 emissions. So as I was anticipating, it's one of our motivation. Now the question is, can we have and build a material that has a similar property than as concrete, but where there's no cement? And we do work with bacteria in this case. It's a collaboration with microbiologists from the University of Stuttgart, and you see we pick different collaborations. There's a long tradition, it was at the time of Rayota also not different, to get to the target. And the target is that the bacteria, and I can show you here, are generating calcium carbonate crystals and binding the particles and creating a strong link. It is a technology which has not been developed by us, but we've been getting it as it was possible to make a low strength system, and we've been controlling the production process and manipulating it, and now we can get 50 megapascal strength, which becomes relevant for us in terms of potential for structural engineering. And now let me get back for a second, and it becomes also interesting for us, since we have to feed these bacteria, it's part of the process, to combine the idea about grading concrete, so about optimizing cavities, also to get a perfect feeding system for the bacteria as well. So there are things that get interlinked even if we are covering a wide range of areas. You can always see there is a link between the different fields and the different expertises, and this is what also this space I was showing at the beginning, our ELEC tent as we call them, it's fostering this kind of collaborations, cross collaborations between the different groups, and this is for us really important to push creativity in the group. And now just let me do at the end a very quick publicity moment, because we do have a cooperative research center, as it is this one, and our symposium is going to be in 2 weeks in Stuttgart. And so you will be able, if you are interested, to join us. I know there are people from Wien coming. There's still time to record and register for that, and then you can see the institute, but you also can see the tower moving in real life, so feel free to join. And then thank you for your attention. I'm looking forward for the questions now.
Thank you so much for this very powerful lecture, connecting also practice and research. You have also addressed very important issues, which is actually constructability and buildability, in particular of novel structures and novel materials. You have addressed the issue of reducing the weight of structures and construction, but not only the weight of construction, but also enabling reducing the CO2 footprint in such way. All of these very important challenges for us as engineers and architects, but moreover interdisciplinary teams. So thank you very much once again. I'm sure we will have numerous questions from the audience, and I see one over there. Yes, please.
Is it on? Yeah. Hello, thank you very much for this very interesting lecture. I'm Zeynep Aksos-Balcar from Technical University. I have many questions actually, but one big question is about your adaptive systems, because I have been reading your papers, and as far as I can understand is that you are basing your systems on the software side on a feedback-oriented manner, and I wanted to ask if you are considering using any reinforcement learning in the future, so the systems actually can learn their own behaviors rather than applying pre-programmed behaviors? Yeah,
it's a very good question. Thanks for raising that. Yes, we are indeed considering that, and there are different aspects that become relevant. Specifically, I was introducing the issue about interaction with people, which is a new opportunity for these systems. And when you interact with people, of course, then that kind of AI-based logic will also become interesting in terms of reacting to models, to behavior, and to learn out of that and to adapt, or to be quicker adaptive to that. And that's part of our research. I didn't show that much because I'm pushing the PhD person to publish on that, and is still a little bit reluctant. But I think it's a classical issue that some of us has to deal with. But yes, this is indeed one of the fields we are working on.
Thank you. Next question will be by Milena Stavric, I think.
Thank you. Thank you very much for your presentation. As I understood, it was the SFB project, and it was for the last 8 years. What is your new plan? What are you doing? Because now you have a nice group of people, and how you plan to go forward with the project and in which direction? What do you think? What is the future after all of that adaptive structures?
Great question. Of course, the plans is to go further, to develop it further. And we have applied for other 4 years, by the way. So we have the chances to get up to 12 years, but they always tell the last 4 years is most unlikely you can get for different reasons. So let's keep finger crossed. But no matter that, we are going to move further on that. As I said already, I see a very interesting chance in the opportunity to complete the overall work on the facade. And by the way, as soon as we complete all the 12 floors, we have the opportunity to restart again. So we have an amazing infrastructure, which is also an exhibition infrastructure. That's why also I was inviting to join. It's a vertical exhibition idea in a way, and it would be a crime not to work further on that. So we have the ministry and a couple of people that will play a role done on the 25th, as it always is in our cases. So that I believe that there will be support for that. This is one part. And so we will keep working on adaptive systems. We are planning to have the first adaptive RIPS lab inaugurated next year, just as a kind of outlook. We are currently working on that. I cannot show yet the pictures, but it's coming. I can tell that already. And but on the 26th we will present it, so it's another teasing moment. And then we do work further on all the concrete research as well. So these two fields become relevant, or will keep their relevance, better said. There's going to be a third field I'm now more and more relying to, and this is how you can deal with existing buildings. It's not, I mean, if you look into the targets, it's clear why we do like that. But of course, there are a lot of specificity. And before you demolish, you can always think about transforming parts of an existing building, which fits to what I presented and to our approaches, without having to demolish everything. And so this is the third field we are now building. And by the way, the work on the concrete is going to be presented at in Vienna then next year, but I will just tell more then later on when I know more details about that. So we are also working on the next generation of the Marina Resa's coral tree, and it's going to be presented here.
Great news. The next question, please.
Dr. Blandini, I also want to say a very brilliant presentation. Please come next year if it's possible. I have one question about your structural models. You showed us that you have some kind of in-house developed system where you go from CAD to structural models to BIM, and
right.
I assume it's circular, or do you use some kind of machine learning to optimize these structural models? When you perform optimizations, for example, you showed us this adaptive structure with a 50% reduction in the...
This is a bit the kind of no, first, not, or better say it, not yet. We have some optimization tools that we developed, but it's not as consistent as the ones we are developing in the research. But of course, the overall idea about the integral approaches that we want the research, or at least the most relevant parts and most mature parts of our research work, to affect the practice work. So that's, of course, the idea that will affect the next generation of structure. You see there is a kind of evolution paths over the last, at least in the work of the office and of the work I've been doing over the last 15 plus years. And so there is going to be the next evolution for sure, and then certain things will flow in.
Okay, do we have some further questions? Yes, please.
Thank you for the lecture. I have a question about the concrete research, bioconcrete. What is the end? Do you think that the clinker will be replaced, or it will be kind of alternative to have a bioconcrete? What is the target there? Like, I understand that we are trying to replace clinker because of CO2, and what is ideal situation on the...
Just to answer to the first question, I hope there's going not to be an end, but in a kind of real way, because that means we've been failing, but all of us. But I see the outlook to me is to reduce the amount of concrete wherever it's possible, to think it more consciously through where concrete makes sense and where it is not making sense, and to find substitution as the bioconcrete in certain cases. So it's a mixed strategy, what I see, and the overall target is, of course, to go from the current 8% and CO2. If we look into that, I mean, there is also an issue about resources with sand and gravels, but just go drastically down. So whatever research idea we are following, I said before, we are not focusing to one material, even though concrete has a certain role in our work. We push to have a 50% reduction in something, in the parameter we are looking into. This is the kind of ambition and target, because this is where we have to hit to. So this is where we see the target. And I see that the target of the concrete industry is actually to go, if you're now looking into this field specifically, is to go far beyond reducing from 8 to half of it. And if you think that the Marinaresa or the other lattice concrete structure are ready just by a geometrical and optimization made possible by or materialized in a proper way, you can reduce 60%, take 60% of the mass out of a massive equivalent. Then you see that here the potential is to go far beyond 50% reduction. But that is a moment where it's not only us and all the key players have to play with.
Thank you very much. Thank you very much for this very inspiring and challenging lecture for our minds and thoughts. And I'm sure there will be a lot of talk about future joint collaboration. We're looking forward also to your symposium and also to greet you in Vienna in next year. Thank you very much.
Thank you.